How can a computer train itself to play Mario Kart? As you can see, our computer will need some help in order to not get blocked on the first 10 seconds. For my final master project, I had to achieve this objective by using artificial intelligence techniques. In this video, I'm going to explain you it in an easy way to understand. First of all, you should know that this project is built on top of two areas of artificial intelligence. From one part, we have artificial neural networks, which are capable of processing images. Then we have reinforcement learning, which is used to train an agent over those images. An artificial neural network is a computational model that tries to mimic the way human brains work. It emulates the interconnection of a great number of processing units called neurons, which are distributed in layers and connected between them with a weight W. Each neuron is going to receive an input data X. And in order to propagate values to the next layer, we calculate the below equation. This includes the weights, the input data, and a constant called bias. The result is then passed to an activation function, which is usually nonlinear, so that the network learns complex tasks. Our neural network is composed of multiple convolutional layers. They are very good at extracting features from an image as they convolve multiple times over it. Our neural network needs some guidance in order to play Mario Kart. We use reinforcement learning to adjust the configuration of the neurons. Reinforcement learning is a type of machine learning technique that enables an agent to learn in an interactive environment by trial and error, using feedback from its own actions and experiences. The agent executes an action AT, which has a consequence on the environment. This is a new state where we will decide whether to punish or give a reward. Based on the gathered experience, the agent learns to take the right decisions. In the tic-tac-toe example, the environment is the board, which is in a current state. If the agent takes good decisions, we will reward it until it wins. The implementation of our neural network uses proximal policy optimization, also called PPO, which is used in order to adjust the values of our network by using policy gradient methods. We have used three convolutional layers, as you can see on the right, and a final dense layer, with as many neurons as buttons our agent was able to press on the game. The output of the neural network is the action that the agent needs to take on the game. In order to reward our agent, we used a wrapper to retrieve memory addresses from the game. We found a variable used for the friction with the circuit. When the friction was low, it meant that our agent was driving over the asphalt. Otherwise, the friction was high when the agent was driving over the circuit outdoors, like grass or sand. We reward the agent each time step it is driving over the asphalt. As you can see on the graph, our agent started to understand the game after 2 hours and a half of training time. In total, our agent used 30 million time steps. One of the biggest problems of machine learning is overfitting. This occurs when your network learns too well on the training data and is not able to predict correctly with other datasets. In my case, I trained my agent over the pitch circuit, but it can also drive on different environments, like the Mario circuit. So that was all. Thank you so much for watching the video, and I hope that this will increase your interest on artificial intelligence.